Good morning. Today we shall discuss optical fiber communication in detail. Communication means transfer of information from one place to another. And for this we use carrier wave communication. Normally, for sending this wave from one place to another, we use radio wave or microwave. In AM broadcast, the normal range of frequency is from 600 kHz to 2 MHz. Suppose we want to send a sound of highest frequency 20 kHz or it is 0.2 MHz. And if we choose a carrier frequency of 1 MHz, then the frequency range of amplitude modulated wave will be 1.5 plus or minus 20 kilohertz or 0.2 megahertz. That is 1.48 to 1.52 megahertz. So this range 1.48 to 1.52 megahertz, its bandwidth is difference between 1.52 and 1.48. That is 0.04 megahertz or it is 40 kilohertz. So if we select the amplitude modulated way of transfer of these waves, then in this AM broadcast, the difference between maximum and minimum is 2000 kilohertz minus the 600 kilohertz, that divided by 40 kilohertz, that is the bandwidth needed for sending one carrier wave. So it is equal to about 35 channels. So in this entire range, we can see that we can send only 35 channels. In radio transmission, we want to send only audio. But in TV transmission, we want to send pictures as well as audio. So here we need more bandwidth, that is about 5 megahertz. And for TV broadcast, carrier frequency range is from 500 megahertz to 900 megahertz. And if we use optical wave instead of this, then optical wave frequency is very large. It is from 10 raised to 14 to 10 raised to 15 hertz. So if we use optical wave for this transferring pictures and audio, then information transmission capacity will increase to very high value. Advantages of optical communication system. Here the information carrying capacity is very high since its bandwidth is wide. For long distance communication, the system is very efficient since it has low power loss and it requires only small number of repeaters. Fiber optic cabling can be used in creating networking in office building since it can save space in cable ducts. Optical fiber cable is immune to electrical interference. Hence, there is no crosstalk between signals on different cables and no pickup of environmental noise. Fiber cables do not conduct electricity, which makes a fiber good solution for protecting communication equipments located in high voltage environments such as power generation facilities. Fiber cable can also be used in environments where explosive fumes are present without danger of ignition. The main components of an optical fiber communication system are the optical transmitter, optical fiber, and the optical receiver. The optical transmitter usually consists of a laser diode or a semiconductor LED. These light sources are modulated in accordance with the signal to be transmitted by changing the current through the source. These encoded optical signals are then transmitted through the cabled glass fiber. At the receiving end, a semiconductor photodiode or phototransistor receives and decodes these optical signals. For long distance transmission, repeaters are used in intermediate stages to amplify the peak signals. In the block diagram of optical communication system, A represents the microphone of the telephone. Here, sound waves get converted into corresponding electrical signals. This B represents the pair of wire which convey the electrical voice signals. C represents the encoder. Here, continuous electrical signals are coded into digital electric pulses using an analog to digital converter. And this D represents the digital electrical pulses proceeding towards the optical transmitter E. This optical transmitter, which consists of an amplifier and semiconductor laser or LED. This E generates optical pulses, that is electrical pulse coded signals. And F represents the optical fiber through which the optical pulses propagate from one place to another. And when they reach at this G, here G is optical receiver that contains photodiode or phototransistor. And here there will be an amplifier also. Its output is an electrical pulse coded signal. And that is represented by letter H. And I represents a decoder. Here the digital or coded signals are converted back into continuous electrical signals by means of a digital to analog converter. And J represents wire pair which carry the electrical output signals from J to this K. And K is the telephone receiver. And here the electrical signals are converted into corresponding sound waves. Optical fiber communication systems can be broadly classified into two groups. First one, local and intermediate range systems where the distance involved are small. Second one, long haul systems where cables span large distances. Local area networks or LAN is a computer-oriented communication system. LAN operates over short distances of about 1 to 2 km. It is multi-user oriented system. In LAN, a number of computer terminals are interconnected over a common channel, allowing each computer to use data and programs for any other. An optical data bus offers a great reduction in cost and increases the information handling capacity. Long haul communication is one of the most important applications of optical fiber communication. Here, it is used for long distances, that is 10 km or more. Telephone cables connecting various countries come under this category.